In this video, we're going to learn how to solve quadratics with graphing, and we will focus on using our TI Inspire CX calculator. First, what is a quadratic equation? Well, the standard form of a quadratic is this: ax squared plus bx plus c is equal to 0, where a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the linear term. You'll see this is similar to the one we've studied previously, ax squared plus c. Now we have a linear term, we call it. We have an x term in here. This will, if there is this x term, the parabola will no longer have a vertex on the y-axis. It'll be shifted to the left or right. The vertex will be in some other position. So if there is an x term, c will no longer indicate the vertex by itself. We'll have to investigate a little further to find where the vertex is. All right. An important concept for solving quadratics with graphing will be to locate the x-intercepts. Well, the x-intercepts are the points where the graph crosses the x-axis. At an x-intercept, y will be equal to 0. When we study our straight line, the y-intercept was very important to us. Typically with the parabola, the x-intercepts are going to be slightly more important. Since it is a parabola, we will often have two intersections. We're talking about a U-shaped curve, so typically, oftentimes, it will hit the x-axis twice. Occasionally, the vertex will rest on the x-axis. There will be one x-intercept, and sometimes the parabola will be always above or below the x-axis, in which case there will be no x-intercepts. All right. How do we solve a quadratic equation by graphing? That is our driving question today. All right. Step 1. Set equation equal to 0. That is, we're going to achieve this standard form. If it's not equal to 0, we're going to simply do some adding or subtracting such that it is equal to 0. Step 2. We will graph, and we're going to today use the calculator. Use calculator. Step 3. Find the x-intercepts. And step 4, check our answer. Verify with substitution. All right, let's see if we can work an example. So we're given the quadratic equation x squared minus x is equal to 12. Okay, so our first step is to set the equation equal to 0. In this case, it's equal to 12, so we want to get a 0 on the right-hand side. How are we going to go about that? Well, it's a positive 12, so we'll simply subtract 12 on both sides. I'm employing the additive inverse. We could think subtracting 12, we could think adding a negative 12. Subtracting 12 on both sides of the equation. 12 minus 12 yields 0 on the right side. These are all unlike terms. X squared minus x minus 12. I cannot combine any of those, so I'll leave it just like I see it here. X squared minus x minus 12. Alright, that's step 1. Step 2 says to graph. Well, what we're going to do in this case is we're going to essentially substitute y in place of this 0 using my TI Inspire calculator. Alright, so here I'm going to my calculator. I went to the Scratchpad grapher. That is from my home screen. From home screen, I chose B for graph. Okay. It says f1 of x. I'm in my function notation. If you're not in your function notation, you could go to Menu, 3, Graph Entry Edit, and choose one function. Alright. I'm going to graph this function. Instead of this equals 0, I'm essentially changing this 0 to y. And we know f of x is another way to state y. So now I'm simply typing in x squared subtract x, subtract 12. Alright, and I'm going to now graph this parabola. We expect a U-shaped curve. And there it is. Okay, there is our U-shaped curve. Well, I want to find the x-intercept, step 3. Well, looking at my picture, I can see that my x-intercepts are at 1, 2, 3, 4, 0 on the right, and negative 1, 2, 3 on the left. To be sure of that, I could look at the table. Control T. I want the values such that y is 0. And here we see 4 pairs with 0, just like we saw in the picture. There's 4, 0 right there. And scrolling up, we expect negative 3 to pair with 0. Negative 3 pairs with 0. Those are our solutions. If the point is not clearly on an integer value, and we can't clearly see it on the table, the calculator can still help us find it. I'm going to go Control T to remove my table. Now I want to find this point on the left. Menu. 6. Analyze graph. Previously, we have found the minimum and the maximum. Now we're going to find the 0. A 0 is an x-intercept. 1. Well, lower bound, I want to move this line so that it's anywhere on the left of the point I'm looking for. This will be fine. I hit enter. I then extend it until the gray area covers this point I'm trying to find. No gray area in this spot. I hit enter for the upper bound, and we see that that point is 4, 0. Alright, so step 1, we set the equation equal to 0. Okay. Step 2, we graph. And essentially when we're graphing, we are changing this 0, we are substituting a y here. So what we're finding are the values where y is equal to 0. And what values are those? The x-intercepts. Step 3, find those x-intercepts. In this case, it was x equals, again, 4 and negative 3. I will write 4 and negative 3. This is not an ordered pair. This is two x-intercepts. This is another way to state 4 pairs with 0 and -3 pairs with 0. But in this context, we're only interested in these x values. This is 4. This is -3. This represents two different points. These are the solutions to the original quadratic equation. Step 4, we're going to check this through substitution. Well, our original equation was x squared minus x equals 12. I'm going to substitute both 4 and -3, so we'll need to substitute twice. X squared minus x equals 12. Substituting 4 in place of x. So here we have 4 squared minus 4. Is that equal to 12? And now -3. -3 squared minus a -3. Is that equal to 12? We want to see if these yield true statements. So I'll come to my scratchpad calculator. Menu A. All right. I want 4 quantity squared, subtract 4. Is that equal to 12? It is. This is a true statement. I could use my calculator on this one, but let me see if I can do this in my head. Well, -3 squared is -3 times -3, that's 9. Minus a negative is like plus, so 9 plus 3, is that 12? That's true too. So we see that 4 and -3 both satisfy our equation. They both give us true statements. Therefore, they are the solutions. I'm going to come up here. X equal 4 and -3 are solutions. They are values that make the statement true. Okay.